So here's a question that was asked over email. It's from section 4.5 and problem 19. Directions just ask you to solve, and they give you 6 to the negative x plus 4 and then equal to 29. And in this problem, any type of problem, when you have a variable in an exponent, if you're unable to write the bases in the same base, then you're going to have to use a logarithm to pull the variable out of the exponent. Okay, so you can either use a natural logarithm, which is abbreviated the ln, or you can use a logarithm, just a regular log. I like the ln, so I think I'll use the ln in this problem, but you can use either one. And since I can't write these in the same base, I can't write 29 in the base of 6, and I can't write 6 in the base of 29, then what I'm going to do is I'm going to take the natural log of both sides. So I'm taking the ln of 6 to the negative x plus 4, and on this side the ln of 29. Okay, there is a logarithm rule that allows us to take this exponent now and bring it down out front. And that's our power rule in logarithms. And I guess I could just write, if you have log base a of m to the r, that is equivalent to bringing the r down out front and having that as r times log base a of m. Okay, so I'm going to bring this down. It's a negative x plus 4, but it's actually negative x plus 4 as a quantity that's multiplying the ln of 6, and that's equal to the ln of 29. All right, now there are two things that you could do from this point. You can actually divide by the ln of 6. You're trying to isolate the x. You could divide this out and then subtract 4. Or you can distribute the ln of 6 through and then solve from there. I think it's probably easier to just divide it out at this point. So if we divide both sides by the ln of 6, then it's going to cancel on that side. We'll be left with a negative x plus 4 equaling the ln of 29 over the ln of 6. Now, these are just numbers, but I'm leaving them in their exact form until I get done, until I'm at the end. Because it's just easier to work with them in the exact form. So, all right, so now what I'm going to do is subtract the 4 from both sides. So I have a negative x equaling ln 29 over the ln of 6 and minus 4. And then this is negative. I don't want it to be negative, so I'm going to divide by a negative 1. That's essentially dividing everything over here by a negative 1 as well. So I end up with a positive x equaling the opposite of the ln of 29 over the ln of 6, and then plus 4. Okay, so if we plug that into our calculator, when we plug it in, and I guess it just depends on the calculator that you have. For me, I'm going to plug this in with, you have to put some parentheses around the top at least. So I'm going to plug it in as a negative ln of 29, and that's divided by the ln of 6. And that gives me a negative 1.87932, and so on, and then I'm going to add 4. Okay, so I get x equals, looks like 2.1207 if I round it. The problem asked us to round to 4 decimal places, so I'll just round it up to a 0.7. Okay, so that's your answer, and that problem should work if you plug that in.